So thank you everybody for joining this early on a Friday morning. We have a few slides to go through and a few things to cover, so I think we'll just jump straight into it. So let's first start off with data center networking, and we're going to look at some of the trends that we've noticed in data center networking. So this paints a picture of where we see general computing in the data center market is going, and what we see happening in the real world in different areas around the world. There's going to be a massive growth, and there's a couple of reasons why we'll see those growths. We're looking at high performance 100 gig requirements. There's RoCE or lossless networking technologies. People want to have visibility and AI ops. And also we need to make sure there's security within this space as well. So we're not just selling switches, or we're not just selling modules or things like that. When we are talking to customers, especially in the data center space, we deliver advanced computing networks to help customers improve their competitiveness in the business. So we mentioned earlier about the 100 gig in the data center. The reality is 100 gig is probably the entry level right now. We're probably going to be looking, or not probably, we're really looking at 400 gig. We'll talk a little bit later about 800 gig within the data center. What's happening is the CPUs are getting more and more cores, and most organizations are moving from 16 cores to 32 cores, unless you're with VMware. We'll talk about that next month, and you have to pay per core. But moving from 16 cores to 32 cores, some cases 128 cores. So if we exceed 32 cores, we're looking at about an 80 gig requirement of throughput within the server space, because if you continue to equip those servers with 25 gig or 40 gig networks, the CPU computing power is going to be bottlenecked because of the network I/O. So that'll be a huge waste of computing power. So 100 gigs minimum in these servers is a requirement, especially. Another thing is we look on the storage side, high-speed NVMe solid-state drives and distributed storage architecture, as well as the massive growth in east-west traffic within these storage classes, all lead to a minimum of 100 gig, if not more, that we need within data centers. So this is a coordinated upgrade, not just on the networking side, but we're also looking and seeing this on the computing and the storage side. So RoCE has been coming on for a long time. It started in 2016, version 2, which started to become mainstream. An idea around RoCE is to make data as fast as access to local memory between distributed compute environments. So as time has gone on, it has become more and more ubiquitous in a lot of environments, and we're going to see this trend continue, especially when we look at AI computing, storage decoupling, the NVMe over fabrics, looking at VXLAN, et cetera, we're going to need high throughput, zero loss, ultra low latency that we're going to need in these environments. Now, speaking of that, some of you might know InfiniBand. When we're talking about massive compute, people often think about InfiniBand as connecting these computing environments together, because they kind of invented that. They actually use RoCE as well within that environment, but it is a closed environment. It costs a huge amount of money to provide that performance, and it's a proprietary protocol. Whereas RoCE is an open standard. It's built on Ethernet protocols and costs a fraction of the price. And right now with 800 gig throughputs, the performance between InfiniBand and RoCE with 800 gig and 400 gig is pretty much on par, the same. So one gets the same performance, the same throughput, the same lossless networking for a fraction of the cost using an open standard and not a proprietary protocol. And so this is where we see a lot of data centers moving within this space. Also, within the space, we need network visualization to be able to see exactly what's busy going on. And so software-defined networking, integration, as well as giving visibility into what's happening. So using AI ops, load balancers, firewalls, all of these need to be presented in a way that people can understand what's happening. So building digital twins, giving the ability to build an intent-based or an intent-driven network, and then given a full flow intelligent analysis of what's really happening within the data center. So this is extremely critical, and this is required and becomes the key capabilities within this environment. Last but not least is security within the data center. Having deep visibility into everything within the data center, who's accessing what applications are running, what are the workloads, how traffic is interacting, is a key requirement. Precise access control, like gatekeepers or traffic rules maybe, to granularly decide or provide rules for north and south traffic, but for the more critical east and west traffic. So building network segmentation, building strong firewalls within this environment, drawing clear boundaries to make sure that the traffic only gets to where it is allowed to go, providing real-time threat protection. So these are the things that we are seeing within the data center, and that is critical to what we need to do. So we're going to continue with our ADDC solutions within the space. This gives us the visibility across the board to see clearly, to see precisely, and to also see ahead. So knowing exactly what's going on where, using AI, being able to troubleshoot and analyze where the problems are, and then quickly be able to pinpoint where those problems are and to be able to resolve those issues, and then build a digital twin, simulate what the changes could be, build a closed loop network. So if something happens that shouldn't happen, to be able to automatically repair and fix those things, including some third-party devices as well. So proactively and preemptively make sure that the business risks are brought down as low as possible. Within the data center space, we have quite a variety of switches. I'm just going to put my laser points on quickly. So these were our first generation DDC switches, and I will talk about these just now. These are the second generation DDC switches, where we are building 800 gig networks, and we can go from chassis or what we call boxes, and then various requirements and various switches that we have, 400 gig, 800 gig, 100 or 200 gig switches. We can build those solutions for our customers. We have very high density port switches, non blocking, to be able to deliver this. So what does this look like in a typical example? So when we're looking at DDC, diversified dynamic connectivity, there's a few OEMs in the world that do this. H3C is one of them. And this is building a Rocky network that has multiple dynamic connections and no blocks anywhere within the network, specifically to enable huge amounts of traffic, especially when we're building AI data centers and needing to move data around AI workloads. I spoke about the first generation. It was a K series. Our second generation is the N series, and these are the ones that we build these with. That's just an example. Company B, we have 9 NCFs and 40 NCPs. We're delivering 1,440 400 gig ports. That's 180 servers in total. And in Company X, we are delivering 288 400 gig ports to be able to deliver the performance and the speed that they require. Keeping in mind, this is a fraction of the cost of InfiniBand and using standard Ethernet protocols as well. let's touch on our campus networking. So campus networks are definitely transforming towards AI applications. People are using AI everywhere. You also notice the trend seems to be that in 2022, each person had 3.2 devices on average that needs to connect to the network. We're now looking at 4.1 devices in 2024. In 2026, that's going to obviously be a bit higher. The amount of devices that need to connect wirelessly, it was 55% in 2020, 70% in 2024, and it's projected to reach 85% in 2027, and 80% of IoT devices access the internet wirelessly as well. So Wi-Fi has become a key enabler as well as a requirement for business within a campus network. In my opinion, we are building Wi-Fi preferred enabled networks or Wi-Fi first networks, because the majority of devices being released don't really have RJ45 ports. Very few of them do, and the younger generation prefer not to connect or be encumbered by cables when they want to work. And so we're definitely going to see that as well, a massive increase. So the key challenges within a campus environment is to, number one, improve the performance. Obviously, we're going to see a huge amount of growth within that space, but also to optimize the experience of the users to make sure that they get the best possible experience that they can, and then help the administrators and managers of this campus network to get the visibility to be able to manage and operate that network the most efficiently way possible. And then not forgetting that there is security, and we need to have an end-to-end proactive solution. So we're committed to helping customers build these networks. They are future-oriented networks, and they're reliable networks to be able to deliver what our customers and partners need. Now, I spoke just about Wi-Fi 7. Wi-Fi 7 is mature, and it is becoming the top choice for enterprise networks. So the market is growing steadily. When we look here at the market growth, we can see how the adoption rate is climbing and the market share is climbing massively. We are probably going to see a 35% market share of Wi-Fi 7 by 2026. So that means that the adoption of Wi-Fi 7 is growing at a phenomenal speed compared to the previous generations of Wi-Fi. And the reasons why is performance. According to WBAP tests, it's 2.5 times faster than Wi-Fi 6E and 6 times faster than Wi-Fi 5. It can cut latency down to less than a millisecond. So it makes it ideal for hybrid work in all kinds of different scenarios, cloud-based tasks or high definition video or AR or VR scenarios. And then there are policies that are busy pushing this. For example, the EU has opened up all the frequency bands at the end of 2025 for the 6 gigahertz band. And that could boost the Wi-Fi market by about 14.7% annually. And then carriers are busy rolling it out faster and faster. We're seeing more and more Wi-Fi 7 home routers and CPEs that are being delivered, and we expect that to grow by 35 to 40% as well. So with this trend in mind, H3C has a wide range of different Wi-Fi products for different scenarios, giving it firstly great value for money. And this helps our customers to build into a smoother, faster, more stable wireless environment. We've seen in some cases our Wi-Fi 7 products pricing is very competitive to our competitors' Wi-Fi 6 or Wi-Fi 6E products. So similar pricing. So it makes sense to move to Wi-Fi 7 now and future protect the network as more and more devices become Wi-Fi 7 enabled as time goes along. Our AD campus solution is something that we are going to continue to look at this year as well. We can achieve multi-network convergence, so not just wired and wireless, but also our all optical network. This is something we'll be discussing in the next couple of months when we introduce this in more detail. Some of you might already have heard about it, and we'll talk about that briefly as well. So we are able to provide a single view of everything and have policies cover all aspects of the converged network. And so we will optimize, secure, and reliably protect everything that goes on within this network environment. Another thing that we're going to continue with is our CloudNet solution, which will continue to deliver, and we'll see just now some of the extra things that are going to be coming with CloudNet. You may have seen the announcement I posted where we have just recently launched our CloudNet SD-WAN solution with our firewalls. So that's a full solution that we can use as well. And we're going to continue to optimize our CloudNet platform, especially for use in our SME, SMB, and micro enterprise environments as well. So this is still definitely a use case and definitely something that we are continually advancing as we move along. So this is just a quick summary of our key campus network products and technology using Wi-Fi as an example. Something that is key to remember when we look at Wi-Fi 7 is that the switches need to be able to keep up with the performance. So 1 gig ports are just not going to cut it anymore. For our entry-level APs, we're going to need a minimum of 2.5 gig or even 5 or 10 gig ports to be able to deliver the performance and throughput. Otherwise, what's the point? If you have a Wi-Fi 7 high-performance AP delivering up to 18 gig of throughput across all 3 radios, and you have a 1 gig bottleneck on your downlink port, that's going to obviously not enhance the performance as well. So we are providing switches to be able to do this. Now, on top of that, Wi-Fi 7 networks, we're delivering high performance, high speed. Some users are going to be requiring 10 gig on the access layer. And so a 10 gig backbone or a 40 gig backbone is not going to be enough either. So having to upgrade to 100 gig backbone is going to be something that is very critical and something we need to look at this year as well. And that being said, H3C obviously has a whole range of technology that supports that too. To optimize the experience, we are going to continue with our AD Net solutions, our application-driven networking with AD Campus, to be able to use software-defined networking to be able to make sure that everyone gets the access and the performance that they are needed as well. In our switches, some of our switches, we are providing firewall cards built in, SDN cards built in. I'll touch on that a little bit later as well, just to make things easier and simpler to deploy. And then also bringing in industrial switches and industrial APs to be able to provide everything that people would need in the IT and OT network convergence too. Being able to operate and manage the network efficiently is key. We have things like our Dr. AP solution, which makes operations and management much more efficient by having a radio scan for any issues and then being able to report back on that, giving us the visualization that we need, and being able to find where those problems are. Wi-Fi 7 APs with edge attack protection also enhances security. And then we're building in firewalls within our switches, in some of our switch models, as well as using firewalls within the network environment, obviously enhances the security as well. So H3C right now has 16 different Wi-Fi 7 AP models. The ones where we see 26 Q1 means that these are planned to be released towards the end of March. It could be a little bit later, but those are the planned release dates. So these are our flagship models for indoor, high density, outdoor solutions, as you can see here. Then we have what we call the balance area. So it's not necessarily a flagship, but it delivers the performance that we need. And then we have the cost-effective devices down the bottom that we're busy releasing. Then the different scenarios, our wall plate APs for hospitality environments that we have, as well as specific APs for the industrial environment as well. Some of the advantages of H3C is that some of our APs are able to switch the third radio between 5 gig and 6 gig. So this means that if the network right now, we rolled out with Wi-Fi 7 and nobody within that organization has a Wi-Fi 7 device, instead of wasting the third radio to do nothing, enable it to run 5 gigahertz for now. And later on, as more and more devices start becoming Wi-Fi 7 enabled, switch that radio to a 6 gigahertz radio to be able to support the Wi-Fi 7 within that space too. 10 gig SFP ports, I spoke about that earlier. So running fiber, this also ties into our all optic network, which we'll talk about in more detail later. Some of our APs have a PoE out ports as well. I spoke about the scanning radio. The ones with an I on the end, like the 733i, as an independent scanning radio, and then the different APs within those scenarios that we have as well. So let's look at our top pick. So for our indoor, I've wanted to mention our beloved soccer ball has got an upgrade and is a Wi-Fi 7 enabled device. Those that know our Wi-Fi 6 soccer ball that we had, it's been upgraded to Wi-Fi 7 now as well. So being able to give the performance there that we need. So our indoor flagship model is the 7638. That gives us high performance, and that gives us the ability to switch the 6 gigahertz radio to between 5 and 6 gigahertz as well. It's built in omnidirectional. We have dual 10 gig ports. So we've got 10 gig copper and 10 gig fiber ports as well. The 7630, that's the soccer ball. Also triple radios. Also has a maximum output of 18 gig throughput, and has built-in omnidirectional. So this is ideal for outdoor environments that we need high performance and cover high density. In the balance range, our indoor APs are the 7020 HIs. So that would be normal use mode, like passages, for example, or offices where there are a few people that would be connecting. This one has two 2.5 gig ports. Then our high density areas, so the 7330i has two 10 gig ports in it, and that would be obviously high density. And then the outdoor AP, this one has external antennas, and so we can put in omnis or directional antennas into this one as well. The throughput and performance is slightly lower than obviously our flagship models. Then our cost-effective ones, the 7320 for indoor, for higher density, the 7232 or the 7220X for outdoor, and you can see the performance metrics down the bottom of here as well. The scenario-based ones are specific APs where we need an indoor industrial AP. So this is our indoor industrial AP we've launched. This is a CPE 5100. It's an outdoor CPE AP. And then the wall plate hospitality AP that's built for specific environments. Keep in mind that this is 86 mils by 86 mils by 40 mils thick. So it may need to have an adapter plate depending on where we're going to be installing it. Our main focus for campus switches, we're adding a few new models. For example, the 5590 is going to have a few models added, which will give us 2.5 and 10 gig models across that entire range. The 5136S is going to add some 2.5 gig models. And the 6550X, we are adding 54 port 100 gig models as well. And these are all already available. Helps us to address competition. Something I'd like to just point out is that the 5130s you don't really see on this screen here. That's because they are slowly but surely going to be OEM, EOM, end of manufacture, and they're going to be replaced with the 5136s as time moves forward. The 5560 is going to be replaced by the 5570 completely. The only 5130s we're going to have are these EIG V2s because they've got the 2.5 gig ports and PoE and non-PoE. The 5590s we've spoken about as well. The 6526s are going to start replacing the 6520Xs as we move along as well. So just keep that in mind as we progress through. And then we'll touch on these ARN switches later. So for our core switches, we'd like to prioritize the 10500 X-Gs, which has a lot of advantages in how the hardware is architectured, the software features. For example, we are able to then obviously provide future expansion within the space, especially for 100 gig high density scenarios and a general good chassis core switch that we have. The 7500 can be used for aggregation in large campuses or core switches in small to medium sized campuses. And we are able to do multi-network convergence in here, and we have modules in this switch that are able to assist us with our ARN network strategy as well. For aggregation switches, if we're looking at 10 gig, let's focus on the 6526s. If we're looking at 25 gigs, let's look at the 6530Xs for aggregation switches. If we want multi-gig, so PoE++, then we look at the 5590s, especially those that have got 2.5 or 10 gig ports. If we just need, and 25 gig uplinks, if we just need 10 gig uplinks and 2.5 gig PoE ports, then we would go with the 5130 EIG V2s, for example. Enhanced layer 3, 5590s. If we want basic layer 3, then the 5570s, 5170s, and layer 2 will be our 5000 series, our V6s, which we are launching as well. And they would have some 2.5 gig ports within those. So these are entry-level PoE only switches with 2.5 gig uplinks. Something we've launched, which is very exciting, is that we, within that 10500 X-G chassis that I spoke about earlier, we have an SDN 80 campus card. So it comes pre-installed with 80 campus running. And we can run them as a one-on-one cold backup. The scale is 2,000 devices, so switches and APs, and about 50,000 devices that connect. So in this environment or in this type of scenario, we would not need to run it on any servers or any other hardware. It can run straight within this chassis as well. So we are able to then provide a network management, a Wi-Fi management. We are able to automate the network environment and free mobility, be able to give us operations and management information within the Wi-Fi environment, running NAC with our EIA, device compliance checks with EAD, and then do IP and license management by adding a virtual DHCP server as well as a license server within this as well. So the deployment time is reduced by up to 70%. We don't need extra cabling. It's all built in there as well. No separate servers. We save cabinet space and things like that. So our target customers would be those who want to use SDN, but we have competitors within that environment. So let's see what we can do with this. Our other customers where 80 campus is not a must. but they need to buy switches. So we can propose this as an advantage, especially these 10500 chassis as we move along. We are also providing PoE switches, especially because there are still some scenarios where we need high density PoE devices that need to connect. This could be anything from Wi-Fi, CCTV cameras, PTZ cameras, things like that, that we need to be able to provide connectivity to. So this is just one investment and we can keep running long term. So 6 line card slots, we can provide up to 288 PoE++ ports, and on the 12 line card, the 10512X, we can provide up to 576 PoE++ ports as well. And then we can expand the power supplies to deliver the PoE output that we need. This deck helps us to easily identify which campus switches we want to use within the network environment. So if you're looking for a switch that has 100 gig uplinks and you need 10 gig multi, then we're looking at this switch as an example. If you're looking for 100 gig uplinks, but you want 1 gig copper PoE, then we would look at this switch as an example. Or if you want 40 gigs or 25 gigs, you get the point. So this helps us to easily identify which switches within the campus environment are the ones that we could use. If there's something that isn't covered here, then obviously we can just consult and give you a better idea. Now, our all optical network environment uses multi-channel, and that is to compete with other OEMs within this environment to be able to deliver higher density multi-channel in terms of fiber, being able to deliver 100 gig ports. So these 100 gig ports could be split into 4 25 gig ports. So that gives you 425 gig ports downstream to be able to expand the network, for example. So 54 ports times 4, that'll be over 225 gig ports that a person would be able to deliver downstream and using this type of technology. We'll talk about this in more detail in the coming months, but essentially all optical networks reduce the amount of copper required to running cable trays. We're just running thin fibers. In some cases, we just need a single strand of fiber because we will use bidirectional within that space, delivering, for example, connecting APs directly to fiber, or using our hybrid cables where we can go up to 1,000 meters away from these switches. The hybrid cable copper to provide PoE up to 1,000 meters to power the AP or to power a small switch. And then the fiber is what delivers the data to this environment. So there are a lot of use cases in this environment: hospitals, schools, large enterprise campuses. It makes a very good, unique idea, being able to deliver high performance networks without needing to spend huge amounts of money on copper as well. These are just some of the ports. So what we are doing is we are integrating ONUs or GPONs within the same chassis. So we are able to deliver layer 3 routing within a GPON network because of how we integrate these within our chassis environments. And so we are continuously investing in this technology, and we are continuously busy upgrading within this environment as well. So compared to our competitors, as I mentioned, we have the ability to integrate all of this within a single chassis environment. So if there's any requirements, please contact us and let us see how we can assist. Security is a thing that we have continuously been investing in. H3C has been doing security for 15 plus years already. We have a full range of solutions for the international market. The M9000 firewall using class architecture can provide up to 4.5 terabytes of throughput and 480,000 different security policies. It outperforms most of our competitors in terms of its performance. In the campus environment, medium campuses, we look at the F5000 series, which also gives us high density 10 gig. We're also able to put RAID redundancy in by adding additional hard drives. These smaller environments, we're looking at the F1000s or the F100s to compete in this market as well. We also have launched load balancers for the market, the international market as well. So this year we are introducing load balancers to be able to be used, as well as ACGs for small to medium campuses. And then something that is very, very new is our ISOC. This is our SIEM solution that we have, as well as our log analyzer. We've had some customers ask us, do you have an equivalent to, for example, FortiAnalyzer? Yes, we do now. We have this available. And so we can provide a similar type of thing. And then our SMP, which is our security management platform, this gives us the ability to manage all of our firewalls and devices from a single pane of glass to provide a single policy. So one thing that we're going to be talking a lot about within this space, and the next slide, I'll touch on that a little bit more briefly, is our AD Campus basic solution. And this is, how do we propose AD Campus in a conventional VLAN network environment? Because not everyone is ready or has VXLAN environments and is ready to do a complete change out. So the idea is that what we will do is that we will, give me 1 second. What we will do is we will, step one, we replace the core first. We put in the AD Campus to be able to give us policy execution within the core. And then we will then migrate that and replace the aggregation switches as time goes on. And then after that, migrate to change the access switches. So we start at the core and work our way out to be able to do this. So we don't need VXLAN, and so we lower the entry barrier. We lower the barrier for entry to software-defined networking environments. So we also significantly improve the performance by moving in this way. Ultimately, obviously, we would like a VXLAN environment, but for those customers that are not that big, they're not that complex, and but still want software-defined networking, we would use this type of idea. Now, IMC version 7 and IMC version 9 is a thing that has been spoken about quite a lot in this industry. So let's look at IMC. Is IMC still available? Are we still going to be working with IMC? Yes. It hasn't been discontinued. It has a lot of support for third-party modules. We can continue to provide the solution, and we can continue to promote and supply, especially for small to medium industry customers, where there is no need for any more R&D within this environment. We can then continue, and we'll have all these options, or whether we're going with a hierarchical solution, whether we need to manage Wi-Fi, whether we need to manage NAC, we can continue with IMC to give us our basic network management. However, our new AD Campus Basic Edition, which is just a network services manager solution both for switching and Wi-Fi. It used to be called IMC version 9. We don't call it that anymore. But what we are able to do with, if we would go with this platform, is we can expand it. So we can go with our network services management and our Wi-Fi management, and then add on our endpoint management, so our MAC on it, to start with a basic solution. So we call it AD Campus Basic. And by adding on additional licenses, we can upgrade and scale out to a full-blown software-defined network solution, giving us the automation and all the things that we would have spoken about with our AD Campus solution in the past as well. So we could start small and grow and expand into this as a solution. So this is something we talk about, where it's a centralized management environment, and we are busy moving towards running it with H3C equipment. Organizations that do not have H3C, but you want a foot in the door and get something in, we'd probably go with IMC. We are able to use our AD Campus Basic with some OEMs, not as many as what we did with IMC version 7. So if this is the requirement, let's have a discussion. Let's find out what that equipment is, what models they are, and let's see if there's anything we can do. As long as there's an MP and CLI connectivity to those devices, we should be able to, but it's something we're going to have to be able to test and then see. But this would be a strategy and a long-term solution strategy that we are busy looking at, migrating somebody from wherever they are to a full-blown software-defined network running H3C end-to-end. All right, our wide area networking, just in case you thought I forgot about that, we're going to talk about that now. We have a huge range of routers available within this space, from our very small, tiny little routers that have got dual 5G links, all the way up to our huge CR19K chassis. We were discussing internally, and we don't think that we will get to the 19Ks within the South African market. We have actually sold a couple of these CR16 M1As. You may have seen it in the media. To some of our customers have them as well. We also have some of these smaller chassis at some of the ISPs already installed as well. What we do have as well is the RA5000, so especially for IP RAN type networks. These are very, very good. And then our SR66s. So we're doing a lot of work within this environment, and there will be some announcements that will be coming a little bit later as we migrate some of these and consolidate some of these into platforms and devices that have better chipsets, faster performance, etc., and things like that. Now, those of you that are on the WhatsApp group would have seen this announcement I'll send through, I think it was yesterday or the day before, about our CloudNet SD-WAN solution that is now working with our firewalls as well as our routers. Just remember, the CloudNet SD-WAN solution is a subscription-based solution. This is the only subscription-based solution that we had. Our on-prem AD-WAN solution is a permanent license that doesn't expire, and this is mostly meant for large-scale networking and where we need more visibility and higher reliability and a lot of analysis to be able to put in. So the common people here would be telcos, maybe finance or government, energy, transportation, large enterprise environments. On the CloudNet SD-WAN, supermarkets, retail, logistics, and the enterprise sector, depending on how big the enterprise sector is. An environment that has maybe 600 branch offices that only need an SD-WAN solution, no NAC integration within the solution, and managing a couple of switches and APs, for example, this would be a perfect fit for them. That would be the most cost-effective way for them as well. So this is our router portfolio in a little bit more detail that we can see. There are some new devices that we've added to this. We've upgraded some chipsets and optimized some of the solutions. Some of the pricing is very, very, very competitive within this space as well. Here are some solutions that we are going to be releasing. I just want to see, these don't have the dates in now. Towards the end of the year. It says 2026 and 10, so we're looking towards the end of the year, early next year. This is an industrial 4G router. that will replace the MSR 10. We also have a bus router that we are actively busy developing right now as well. And then this SR6608ME that we are busy developing as well, which will be replacing the 5600. Something that's very interesting is this IR1311V, which we have, and the VE, which is coming H2, is a way for our carriers to provide devices for home routers, where they either are going to connect with a fiber line or a 5G breakout failover, and they need a FXS port to be able to connect a SIP line to it as well. And we are able to provide these too. And if there's any use cases, please come and talk to us and we'll see what we can do. There's a minimum order requirement for about 1,000, I think, because we're talking about carriers. So when we go and talk to those, we can do some POCs, some tests and some things, and then provide those for them to go in as well. I wanted to just touch on the roadmap for our software-defined networking solution for you to see that we are continuously looking at and enhancing our solution. So over the next 2 years, there are going to be a couple of major upgrades. In 2027, we will have fully integrated AI technology into our solution. So AI will be used to optimize our SD-WAN, to identify all the traffic, as well as to optimize SaaS applications as well. In 2028, we are evolving further into a full SASE solution, as well as ZTNA as well. So yes, we are developing and working on our own SASE solution. It has actually been launched in China. It's running tests and trials within the Chinese market, and we'll be launching that planned launch in 2028. And this just shows the roadmap and a couple of the things that are going to continue to iterate and evolve as time goes on during 2026 as well. So additional features coming within this year, and CloudNet, we are going to continue to evolve as well within these two platforms. So there's a lot of things happening within our network environment. I hope I've covered a lot of this for you and explained a lot to you. And if there's any questions, please feel free. I don't know if there's been any in the Q&A. Is anyone asking any questions? No one's asking any questions. Anyone want to ask any questions now or post questions, or do you want to send them to us as DMs?